and Jai Hind children. I welcome you all in today's live class of chemistry. Children, we are discussing the chapter acids, bases and salts. Is it? And in previous class, I have explained you the types of acids, that is mineral acids and organic acids and concentrated acids and dilute acids. Is it? So I hope that you understood those topics. Now today I am going to start the next topic of the chapter, that is properties of acids. Alright? Children, the properties of acids indicate their features. Okay, so all the features or properties of acids can be categorized in two groups. That first group is physical properties and the second group is chemical properties. Alright, so we will discuss one by one these properties of acids. And first of all, we will explain the physical properties of acids. Acids have many physical properties. Like the first one, it have a sour taste. Children, I have explained it in the first period of this chapter that acids are having sour in taste. So this sour taste is one of the physical properties of acids. Okay. Now the second physical property is it turns blue litmus to red. Okay, that is why when we put a drop of lemon juice on blue litmus paper, that blue litmus paper turns to red. So this is a physical property of acid. So we can say that the first physical property of acid is it is sour in taste, and the second physical property, it turns blue litmus to red. Okay. Now the third physical property is all acidic solutions conduct electricity. Okay, children. So you can see that the electric current can pass in acidic solution. It may be the lemon juice. Okay, it may be the orange juice. So in these all acidic solution, the electric current can be conducted. Okay. Now the next physical property is all the acids are corrosive in nature. Children, do you know the meaning of corrosive? It means that when it kept or when it falls on cloth, paper or wood, so they destroy it, they damage it, and this nature is known as corrosive nature. So all the acids are corrosive in nature. Okay, so the strong acids can destroy the substances like paper, cloth or wood. And the acids also corrodes metals such as iron metal and aluminium metal. And therefore, the acids are not stored in metal containers. Okay, children, it always is stored in glass container because it will not corrode the glass. It can corrode the metals. Okay. Now the mineral acids, except the carbonic acid, causes the burns on the skin. If they falls on our body, on our skin, so it can burn, and therefore it should be handled very carefully. All right. That is why you are always advised while going in chemistry lab, don't touch the chemicals. because they are certain acids and the skin can burns. So that is why we never use the acids by yourself. You must use it with the help of your teacher. Alright. Now the next physical property is it is soluble in water. So the acids are soluble in water. And when an acid is dissolved in water, a dilute solution of the acid is formed and the heat is given out. Okay, when we add the acid in water, so the heat produced, and that is why that solution gets warm. And for this reason, it is dangerous to add water to acid. But if we want to dilute an acid, so always add acid to water, not water to acid. And this addition of acid to water must be done very slowly with constant stirring of that water. Okay, understood, children? So I hope that you understood these all physical properties of acids. Alright, now let's start the chemical properties of acids. Children, we will discuss the chemical properties of acid one by one with certain substances. Like first of all, we will discuss the reaction of acid with metals. Okay, so all the acids they contain hydrogen atoms in it, and the dilute acids react with some metals to form salt and hydrogen gas. Alright, and the metal replace the hydrogen of acids from salts. So we can say that when the acids get react with metal, it forms the yes a kind of salt and also produces the hydrogen gas. For example, if we take the magnesium, the symbol of magnesium is Mg, is it? So this is magnesium. And when the magnesium get react with hydrochloric acid, this formula of hydrochloric acid, children, you know very well, HCl. So when this reaction will occur, it will form a salt, that is magnesium chloride. And the symbol of formula of magnesium chloride is MgCl2. This is magnesium chloride. And along with this magnesium chloride, hydrogen gas will also produce. Okay. So this is the reaction occur when hydrochloric acid reacts with magnesium. Now children, this reaction is not balanced this time. And you know how to balance the reaction, is it? So if we increase the molecule of hydrochloric acid, so this reaction gets balanced. So this is a balanced reaction in which magnesium reacts with hydrochloric acid. It forms magnesium chloride salt as well as produces the hydrogen gas. Okay. Similarly, if zinc metal, the symbol of zinc is Zn. When this zinc reacts with sulfuric acid, the formula of sulfuric acid, children, you know, Yes, it is H2SO4. So H2SO4 is the formula of sulfuric acid. When they both react, it form a salt, that is zinc sulfate, and the formula of zinc sulfate is ZnSO4. So which salt is this? Zinc sulfate. Alright, and along with this salt, it also produces the hydrogen gas. Alright children, so these two examples shows that when acids react with metal, they form the salts as well as produces the hydrogen gas. And similarly, as magnesium and zinc, similarly sodium, potassium, calcium, iron, lead, and aluminium, they all replace the hydrogen from acids and to form the salts. Okay, and in this reaction, the less reactive metals such as copper, silver, and gold, they cannot replace the hydrogen from the acids. Okay, so we can say that reaction will not take place in case of copper, silver, and gold because these metals are less reactive metals. Got it? So I hope that you understood the first chemical property of acids, that is reaction with metals. Okay children, very good. Now come to the next chemical property of acids. And the second chemical property is reaction with carbonates. Acids also reacts with carbonates like calcium carbonate, sodium carbonate, and so on. And during this reaction, they forms the, yes, salts, water, and release the carbon dioxide gas. Okay, children. So, what product will form when that carbonates react with acids? They form the salts, water, and carbon dioxide. All right. Now, take some example. So, the first example I'm going to take is calcium carbonate. The formula of calcium carbonate is CaCO3. So when calcium carbonate reacts with hydrochloric acid, and the formula you know very well, HCl. So this is calcium carbonate, and this is hydrochloric acid. When they both react, they form the salt, and the salt is calcium chloride. The formula of calcium chloride is CaCl2. So which salt is this children? Yes, it is calcium chloride. And along with this calcium chloride salt, water and carbon dioxide will also form. Alright children, so this is the chemical reaction when the calcium carbonate reacts with hydrochloric acid. It forms calcium chloride water and carbon dioxide. Children, this reaction is this time not balanced. Okay, and for balancing it, we will increase the molecule of hydrochloric acid. So, when the two molecules of hydrochloric acid will react with one molecule of calcium carbonate, it forms one molecule of calcium chloride, one molecule of water, and one molecule of carbon dioxide. Okay, now take another example. And in this example, we will take the sodium carbonate. The formula of sodium carbonate, children, Na2CO3. Okay, this is sodium carbonate. And when this sodium carbonate will react with sulfuric acid. Okay, so H2SO4 is the symbol of sulfuric acid. So when they both will react together, they will form the salt of sodium sulfate. The formula of sodium sulfate is Na2SO4. This is sodium sulfate. Okay, and along with this salt, sodium sulfate, water and carbon dioxide will also form. Alright, children. So this is the chemical reaction in which sodium carbonate reacts with sulfuric acid to form sodium sulfate salt, water, and carbon dioxide. Okay. And the reaction of this sodium carbonate with sulfuric acid is used to prepare carbon dioxide in the laboratory. Okay, so this one is the second chemical property of acids, that reaction with carbonates. Now come to the third chemical property of the acids, that is reaction with bases. Remember that we already have discussed about the acids and the bases. So here in this chemical property, I will discuss that when an acid react with bases, okay, so what will form? So the reaction of an acid with a base to form a salt and water. What product will form, children? Yes, it will form salt and water. Okay, and this kind of reaction in which an acid react with base is known as neutralization reaction. Understood, children? So what these kind of reactions are known as? Neutralization reaction. So children must remember such kind of reactions in which an acid react with base to form salt and water. Get it? And along with it, heat will also evolve. Okay, so such reactions are known as neutralization reaction, and generally we can write it as acid react with a base. So they will form a salt plus water, and along with it heat will also evolve. Okay, so this is the general equation of neutralization reaction. Okay, children. Now the reaction gets its name neutralization because the acid and the base cancel out each other's properties. Okay, that base cancels the acid properties, and the acid cancels out the basic property of the base, and that is why they gets neutralize the effect of each other, and as a result the name of this reaction is given neutralization reaction. Okay, in this process of neutralization reaction the heat is always produced, and that is why the test tube feels warm after the reaction. The test tube in which we are going to mix an acid with a base, so we feel that test tube gets warm because of neutralization reaction. And the salt which are produced, it may be the acidic, basic or neutral in nature. Alright, so these are some common features of neutralization reaction. Now take some example of neutralization reaction. So the first example I'm going to take, when potassium hydroxide, which is a base, and the formula of potassium hydroxide is, children, yes, it is KOH. So KOH is the formula of potassium hydroxide. It is a base, and when this base is going to react an acid, that is sulfuric acid. Okay, and the formula of sulfuric acid, I hope that you know very well. It is H2SO4. Alright, children. So when this base and this acid reacts together, they form a salt, that is potassium sulfate. Okay, which salt will form? Potassium sulfate, and the formula of potassium sulfate is K2SO4. So K2SO4 is the formula of potassium sulfate. It is a kind of salt. Okay, and along with this salt water will also form. Alright, children, so this is the chemical reaction, but this chemical reaction is not balanced, and you can balance it as the molecule of potassium hydroxide get increased, and because of it the molecule of water will also get increased. So two molecules of potassium hydroxide reacts with one molecule of sulfuric acid, and it will form the one molecule of potassium sulfate and the two molecules of water. Okay, so this is an example of neutralization reaction. Understood, children? Now take one more example of neutralization reaction. And in second example, I'm going to take the base, yes, sodium hydroxide, and the formula of sodium hydroxide that you know very well. It is, yes, it is NaOH. So sodium hydroxide, which is a base, and its formula is NaOH. And when this base is going to react with acid, hydrochloric acid, the formula of hydrochloric acid is HCl. So when this base and this acid react together and form a salt, and that salt is sodium chloride. Which salt, children? Sodium chloride. And the formula of this salt, sodium chloride, is NaCl. Okay, so NaCl is the formula of sodium chloride, which is a salt. And along with this salt, sodium chloride, water will also form. Okay, so this is the reaction which shows that when a base reacts with an acid, it forms the salt and water. So this is also an example of neutralization reaction. Okay, children, one more thing that you must have to remember. The word salt, as I have told, sodium chloride is a salt. Okay, potassium sulfate is also a salt. So this salt here does not refer only the common salt, because the common salt is known as sodium chloride, whereas salt is the common word, and the common salt that we use to it is sodium chloride, which is also a kind of salt. Okay, so that is the general term, and it refers to the compound formed when an acid neutralized by a base. Okay, so the salt is a common word which is used, or which is a compound which form when an acid reacts with a base, whereas the common salt is the sodium chloride. Okay, so I hope that you understood this. The salt is a common word. Okay, a common compound. So this one is the chemical properties of, yes, acids, in which we have seen that the acid reacts with metal, acid reacts with carbonates, and acid reacts with bases. Okay, so I hope that you understood these all chemical properties of acids. Alright, children. Now after that, I will discuss the uses of acids. Okay, because different types of acids are used for different purposes. So we must have to know about the uses of different acids. Got it? Uses of acids. Children, the hydrochloric acid, sulfuric acid, and the nitric acids. These are the most commonly used acids in the laboratories. Okay, and as well as they are also used in several industries. So here we will discuss the uses of these three types of acids, that is hydrochloric acid, second sulfuric acid, and the third nitric acid. Okay, so come one by one. So first of all, we will discuss the uses of hydrochloric acid. Oil bearing rocks, it is used in oil industry. Got it, children? Now the second use of this hydrochloric acid is to manufacture chemicals such as glue. So the second use is to manufacture chemicals like glue. The hydrochloric acid is also used. The next use of acid is to purify the salts which we used to eat and the other salts. For their purification, hydrochloric acid is used. So we can say that hydrochloric acid is also used to purify salts. Okay, children? The next use of hydrochloric acid is to remove scales. To remove scales. Children, do you know the meaning of scales here? It means that the deposits which are formed inside broilers in various industries, and this process of removal of scales is known as descaling. Understood? The scales are the deposits which are formed inside the boilers in different kind of industry. So when these deposits are going to remove, so this removal will take place by using the hydrochloric acid, and this process of removal is known as descaling. Got it? Now the next use of hydrochloric acid is to make aqua regia. To make aqua regia, hydrochloric acid is also used. Children, do you know the aqua regia? This aqua regia actually is a kind of mixture of two acids, and this consists of three parts of hydrochloric acid and one part of nitric acid. Alright, so hydrochloric acid and nitric acid, they both get mixed in the ratio 3 is to 1, and this mixture is known as aqua regia. Okay, and this aqua regia is used to dissolve the noble metals such as gold and platinum. Gold and platinums are known as noble metals. Okay, and this aqua regia is used to dissolve these metals. Okay, children, so these are the different uses of hydrochloric acid: to dissolve the oil bearing rocks, to manufacture certain chemicals, to purify the salts, and to remove scales, and to make the aqua regia mixture. Okay, now come to the next. The next kind of acid is sulfuric acid. Okay, so we will also discuss the uses of sulfuric acid in next class. Alright, children. So I hope that you understood the uses of hydrochloric acid, and in next class we will discuss the uses of sulfuric acid. Thank you and have a nice day, children.